That's fine by me. Well, it's good enough. All right. So welcome to Bad Idea Metals. It's been a few weeks since I've recorded anything, and well, that's not entirely true. I've made a lot of mistakes, but today I'm going to show you some of the things that we've got and why we've got it, and we're going to eventually get to it. So I got all these shells. That's for steel recovery. This granite block right here, this is part of a drill or a CNC, an electronic drill, and you can see I've got two of them. But each one is 2.5 tons, and it was quite literally just dropped right here in my yard. But yeah, that's what we've got around here these days. Pretty fun. I'm gonna tear it apart for the aluminum, the copper. There's a few electrical components. We'll sell the steel. These fiberglass tops, they're garbage, where they're gonna have to go to landfill or something. Yeah, the reason why I'm so excited about these granite tables is let me show you one of the messes that I made last week while I was trying to record a video. I'll walk past all of my fun. So all those shells of machines, I've got a countless number of power supplies and CD-ROMs and all the other stuff that I got. So I've been super sick, super busy for the last few weeks. Went to camp, and I am totally swamped with just stuff that are overflowing. I got TVs everywhere, I got all sorts of stuff. But here is the scene of the crime. So I'll post some of the highlights of the video that I recorded, but look at this mess. I had an extreme overflow. Oh man, it looks like it burned, but that's actually not fire. That is acid burn. You can see the splash marks. I mean, I got it coming down everywhere, and it pretty much destroyed my burner. But beside the point, I had a reaction get out of control, and it boiled over, and unfortunately, that was a huge mess. Oh man, and it really is eating into those iron. I'm gonna have to treat those so I can use them. Shoot. Anyway, but you can see I have a mess. I got a lot of a mess. Everywhere I look, it's a mess back here. So we got a lot of cleaning up to do, but that's what I've been up to. I've been stockpiling everybody else's garbage around here, which is great. More for me to work on. Oh yeah, and this is how much rain we got in the last few days. Usually there's not a whole lot of rain out here. Anyway, I got a lot going on back here. Got the solar panels back there behind the curtains. I still need to get to all this. I'll get to it eventually. All right, let's try this again. I'm Anthony. This is Bad Idea Metals, and the summer has been extremely busy for me. And so I'd like to get back to some of the stuff that I've been having fun doing on this channel for the last 1.5 years. And that's tearing things apart and melting what we find. I'm not going to be able to melt a whole lot of what's in here. Most of what's going to be in here are circuit boards and some steel components and a lot of plastic. But it's been a while since I've been in a Laserjet like this HP here, and we're going to take it apart today. So this is an HP Laserjet. I believe it's a 4250. I don't know much about this specific model other than it's a black and white. It is a network printer, but I don't believe it's a wireless printer. This guy is probably, I don't know, it's probably close to 15 years old at this point. I don't see any markings of when it was made, but here we go. So there's a few compartments that we can open and gain access to toner, to the paper trays and things like that. Oh, here you go. Product information. Here we go. It was actually made in 2008. That makes this printer about 13 or so years old. So not too far off on the guess that it was about 15 years old. There's a ton of plastic. So you're probably just gonna get the highlights here because this could take a while to tear apart. But a lot of the easy to access components seem to have already been removed. There is a paper tray with some steel, and there's a steel roller right here. That may have been off camera, so there's a steel roller right here. There's a steel tray feeder, and the rest of this is gonna be plastic. Really, the stuff that we're excited about is gonna be on the inside. There's gonna be a power supply inside. There's gonna be some electrical workings, some circuit boards and some motors. My estimate on this, the printer weighs about 30 or so pounds. It could be a little bit heavier than that, but I'm guessing it's between 20 and 30 pounds. And a significant amount of that weight will be the steel. Right now, steel prices are about 5 cents a pound. So I would say, if I was to totally guess, this would probably be about $1 to $1.50 if I were to take it over to scrapyard and just say, hey, take it off my hands. Anyway, so right now, my estimate on this is it's going to be about $1. However, with the motors and such at 28 cents a motor, and then some of the chips off the boards we want and some of the copper, I would say that the total value on this, just guessing, we're looking at about $3 to $5 in scrap value after we've got it torn apart. The plastic will hopefully be recyclable. It doesn't have any plastic numbering for the recycling purposes, so it's hard to tell, but it does feel like it's that high density plastic that a lot of places do recycle. But again, the numbers are not here. So let's go ahead and get our bucket off to the side here. We'll put all the plastics in one bucket. We have another bucket on the other side. All the stuff that we want to save goes over there. For this project, I've got a series of Phillips screwdrivers. Most of the things in here will be Phillips. I've got my little guy. This is good for all the small screws, standard screws. And I like my long reach Phillips. That way I can get down deep and I don't cut up my hands on the plastic. I do have my pliers and I do have my wire cutters if we need them, but I'm hoping we won't need them. Also, I like to use a steel bar with the little hard drive magnet on the end. So that way I can reach down and I can pick up the screws that just don't want to come up. Some of my screwdrivers do have the magnetic ends on them, but they don't always. So now that we've got the top panel off, we'll come back for the electronics in the top panel at the end. But let's take a look what we got in here. We got just a side panel, not a whole lot to it, some insulation. Let's go ahead and take this drawer off. All right, set that off to the side too. Show you the side that we just took off. It's pretty much in a steel housing, a steel body with a fan on this side. There's really not a whole lot else other than it's got 30 screws or so right here. This is what's going to hold all of our fusers, our paper feed, the print spooler, everything. It's going to have screws on the opposite side that correspond with the screws on that side, and there's going to be all sorts of rollers there. Let's see, the side that's going to be the most exciting is going to be this side. So it looks to me like this may just pop off. Let's go ahead and grab a tool to pry with. There you go. It did just pop off, revealing Let's take a look. This side has what I can see right off. It's got a transformer motor type deal down here. 2 motors right there. A fan. Our power supply is going to be probably back here inside this housing. It's got what looks like an expansion card slot. That's pretty cool. It's got RAM. Huh. 64 megabytes. PC 100. That's pretty interesting. So this is pretty old RAM. That is a pretty cool processor chip right there. Let's go ahead and take that off. Apparently it slides off. Well, that was exciting. It's kind of a fun little tray. Set that off to the side in our bucket of steel. But yeah, that revealed this card. It's got expansion slots for 2 PC100 RAM cards. They're SODIMM style, so they're your laptop style. It's got this really big chip. It feels funny. It doesn't feel like the standard IC chip. It doesn't feel like a standard BGA. It doesn't have that same matte finish. It's almost like a gloss finish. But let's see what else is on here. We've got pins in here. We've got a network port with pins. We got this serial or this, yeah, it's a serial port. It's got pins. Some other slots here like these pins do. So fun stuff. A few ICs. There's some RAM right here. This just looks like a control ACU. Anyway, we'll put this in our bin of things that we're interested in, and we're moving on. One thing about printers is there's screws everywhere. There's always screws everywhere. So, a comment about something I said a second ago. I was thinking that the power supply was going to be right there, and it wasn't. It looks like the power supply module is actually deeper inside. Probably behind this unit right here. It doesn't look too far off, but the power plugged in right here. So I'm expecting the power supply to be back here somewhere. So we'll find out. It's going to be where a good amount of copper is located, which is very helpful for what we're doing. It's what we're looking for. Got some giggling children over here. Unhook all of these little tiny wires. These wires are most likely copper, but they're going to be such fine grade, low grade copper. It's not going to be very beneficial to us. And just looking down inside, these pin connectors are all they're not gold plated. So this board, it has an IC chip and a few capacitors that I may chase after, but really there's really not a whole lot of value to this board right here. But we'll pull it off anyway. So the cable management inside of printers, it's really interesting. It's pretty cool. It's all sorts of plastic hooks just lined up in the correct way to basically prevent the wires from moving a whole lot. Oh man. You don't want the wires to get in the way of the motors or the paper. If they were to move around too much, then that would be bad. So, oh my gosh. Let's go ahead and snip that. That one doesn't want to unlock. There we go. So, you don't usually see wire management like this in a desktop, but you might find it in a laptop. A laptop computer, a lot of times you'll find wire management similar to this, where plastic hooks basically help direct the flow of the wires. Okay, last screw on these motors. let's take a look what we got. All right. Oh, that's pretty cool. Let's get a weight on this motor here. This motor, are we in pounds or are we in grams? We're in grams, all right. So this motor has its circuit board on it. Can't see it. Speaking of not being able to see. 400 grams. Or just short of 1 pound. So that puts this motor about 20 to 25 cents. And there's 2 of them. Except this one's tied in with the cable management. We'll get it out in just a second. But yeah, this motor, you can see the copper down inside right here. Copper bearing motors. I can either open them up myself and try to recover the copper. On these small, fine wired ones, it's not typically useful. So I'll probably end up selling this one. But we'll put it in the bucket, make that decision later. Grab the second one out. It's got the same cable management clasp on this side. There we go. This is an interesting spring. Careful taking these types of springs off. These types of springs can actually shoot off in random directions, get in your eye. But that should effectively let us get the wires out now. All right, and that fan should be able to come out now too. There we go. So a fan with a little bit of wiring. Oh, let's take a look. Are we free? We are somewhat free. Tied together with the other wire here. Okay, so here's another motor. It's probably also another 1 pounder. So the fan and the 2 motors, there's another fan on the other side. Those are all going to count as electric motors. Basically, if it's got wound up copper, they count those at recycling places as electric motors. Looks like there's some gold pins in here, so even though this is mostly plastic, we'll stick it in our bucket over here to run with our gold pins. Okay, this side is almost all done. There are a few screws that I can take off. Caution, danger. This is where the laser is. Okay, in the event that this were on, you wouldn't want to expose your laser. Most of these are such low intensity lasers, but a laser is still a laser. They're gonna put their warnings on them because they can still do damage to your eyes. Would that be considered an involuntary LASIK surgery? Maybe. All right. There we go. So that's just a panel of steel. Here is our laser house assembly. Now, these are so intriguing to me because they have these lenses that are just really interesting to me how they work. If you look closely here, it's plastic, but are they plastic? They feel plastic. They sound plastic, and I can actually see the cutting marks of the device that made it. This one's tempered glass up here, but these guys, they're such a weird shape. Inside the top of our printer, we have a laser. There's a circuit right here. Take that wire off while we have it. But there's a laser right here, and it fires through this lens and onto this spinner. The laser gets distributed using this set of mirrors that spins across these lenses onto this sensor plate, which is tempered glass. So this right here, I couldn't honestly tell you how this all works. This is like magic to me. It's really cool how somebody has come up with the design that they did. I'm sure there was a lot of trial and error, and there's of course a lot of science, not to discredit the science behind all this, but I think to come up with the shape that they did, a lot of times they probably had to make a few educated guesses based off of what has worked on other printers in the past. So that being said, this is always like magic to me, and I'm always fascinated how these things work, and I couldn't really explain all the details there. Let's pull this mirror or this glass out. It's a piece of tempered glass, and I don't want to cut my hands on them. So let's get these locking springs to let go. I also don't want to break the glass. It's just a little mirror that sends the light back down. And I don't know where it goes, but it goes somewhere. So there you go. Pretty cool. Okay, so that should be the last screw for our mirror assembly. Oh, that's a lot of brass back here. And you can see there's a motor right here. It's kind of hard to see it, but to get this to spin, there are copper coils. So there's a motor, some brass, and I'm guessing this is going to be mostly aluminum up here. There's an IC chip that might be pretty interesting, but the rest of this is steel, and those pins down in there do not look like they're gold plated. They might be, but they don't look like it. But there you go. And there it is. Okay, so on this, there is gold plated leads on this laser diode. Not sure if it's a diode, I guess. Interesting. I guess there's more for me to learn about them, but still, the laser is gold plated, and so that is pretty cool. We are definitely interested in this. So let's set that off into our bucket. Another random piece of plastic, which will now reveal our last screw for this panel. Now these are pretty fun. I like these. They're not going to be very valuable to us. Oh, there's a spring holding on. Hold on. But I like these because it's just a whole set of gears. And they've got a lot of toner on them, so I'm not going to mess too much with them. But it's interesting how all the gearing works inside of a printer. So it's kind of like a car. You got your main torque on your drive shaft, and then that came off of some pulleys or some different gears inside your engine. Well, a printer doesn't work very far off of that, in that there's going to be a main motor, which we've already pulled out, but then it's got to get the motion onto all sorts of different rollers and spoolers and fusers, and some of those will have their own motors, but most of the time they all operate off of their own gear, which all tie into that one master motor. So I think that they're very fancy, they're very fun to see. And these gears went down inside here, and they spin other components down inside. So this is kind of like your main drive wheel that took the power off of the motor and then would transfer it down onto the different spooling elements that need that power. So I love these. They're kind of fun to look at. All right, we've got the wires heading off in all sorts of directions here. There's a few that can let go now. We've got what looks like a toggle sensor here, just a little switch. There's a little bit of copper in these, but basically it's just a magnet that says on or off, an electromagnet. and it's just a switch. Pretty cool stuff. There's gonna be a few of those in here. There's one more right here. It's got blue tape on it. Let's see if we can pry that out. There we go. It does have another small motor in there. Screwed down with a tiny screw. So there is a small motor in here. Get that out. There we go. Okay, so we got our motor out. So these gears are just plastic in a plastic housing. We're gonna set that off in our plastic bin. Steel ring. Okay, so some people like the motors because they're little stepper motors typically, and what's really interesting about these guys, they're really low voltage, so you can do some pretty fun stuff with these. But me, I don't have a use for them, and nobody ever buys them from me, so chances are I'll end up selling this. This guy's about 1/10 of a pound or less, but he'll go in with the electric motors. All right, I'll walk you through all the stuff that I've just torn apart. I just realized that I got a text message and a call, and it stopped my video from recording. So last thing I was talking about was the siding, get the siding off, and then that got me to the fuser, which is this guy down here, and it's this component right here. The fuser, it heats up your toner and locks it onto the ionized page. So I'm really sorry. I'm gonna have to do another video of another laser printer to show you the fun stuff that I was trying to tell you and I didn't get to. But yeah, I got this printer all taken apart. Down here on the ground is the other side wall and the floor. And here's the other side wall. So there's the two sides, all of the rollers. And then here I was explaining to some great detail what I like about power supplies. It's kind of ironic. It was the last component that I revealed. Most printers, the power supply is actually one of the first things that it's usually on the side or just barely nestled underneath one of the motors. But in this case, this was at the very heart of the printer. So here are the components that I really like. These EMI rings are primarily copper, but they have some ferrous material. They're electromagnetic, and they help clean the power as it's going through the system. It helps flatten or regulate the power, from what I understand. I'm not an electrical engineer, so I'm not a pro at these, but these are what I like. You have to get rid of the ferrous material, but you can melt down all the copper, which I do. I've got about 20 or so pounds of these, and sometime pretty soon I'm going to do another video of me doing those. I've already done a video of those, but it's not going to hurt to do another one. Maybe I'll cast the copper into something fun. So I've got 3 of those on here. More copper that I'm not going to melt down are these transformers. There's quite a few of them here in this power supply. There's one more up here in the corner. These are also ferrous. The boxes are iron, and they are used to transform or change the power. So this is the power from the wall. It comes in at about 120 volts here in the United States. In other parts of the world, it could be as high as 240. And that power is going to be too much power for the electrical components inside the system. So some of these components need the voltage to be down between 12 and 1.5. The power has to be brought down to a safe level so it doesn't burn out those components. As the power comes through one of the sides, it's going to induce a current on the other side, which could be 12 volts, for example. This might very well be a 120 to 12 volt downstepping transformer. So that way the voltage coming out would be 12 volts, and then it will go throughout the system, and something may take the 12 volts and move it down to 5 or 7, and something else may take it and drop it down to 3 or whatever. These are just examples. I actually don't know which ones are which. I'm not an electrical engineer. Now, unfortunately, what I lost in the video was what's inside these relays, these white boxes. I've already broken one open, you can see. And what I'm gonna have to do is I'm gonna have to crack it open again so you guys can see the fun stuff that's inside one of these relays. So, inside of a relay is a switch. Oh, come on. This is really difficult to do one-handed. Okay, there we go. One-handed aside. A little bit more. Okay, so inside of these relays are switches. This switch is controlled by an electromagnet. And so inside of those relays is a copper coil and the switch. So as the power comes through, you can kind of see right here, and it's kind of difficult to see it, but this is a toggle switch. And it can open and close the circuit. And so as the power comes through this relay, it tells the power to be on or off. So it's a pretty cool little device. So don't throw these white boxes away. And sometimes they're blue, sometimes they're black, sometimes they're whatever. Like here's a bunch of black ones. I can't confirm that these aren't something else, but I know that these white ones are they're usually power relays. And these relays are wound copper. So if you're not going to melt them yourself, you can sell them as electric motors or wound copper. They're just really, really, really fine grade and fine gauge copper. So, but they're so cool. I like these. But yeah, save those. You can get copper out of them. The last thing that I save off of here is the aluminum to melt. These aluminum heat sinks, they're pretty small, but I save them. They all add up, and then I can make fun things out of the aluminum eventually. But anyway, that's what I have. There are other copper components that you can retrieve. There are these copper elements. I'm not exactly sure if they're heat sinks or if they were something else. But they are copper, so if you're going to strip them off, put them in a bucket, then take all your copper at once to either get melted, melt yourself, or you can take it to the recycling centers and they'll pay copper price for them. So anyway, that's what I'm after on a power supply. I really like power supplies because of the amount of copper on them. Okay, now that I've recorded this twice, let's go ahead and close out the video. All right, so just looking at what I've got here, I really don't think it's going to be all that much. Probably closer to $2 to $3 worth of value. The gold components, there weren't very many of them, but that laser, if you get enough of them, I guess it could add up. But in this case, no, there really isn't a whole lot of value to tearing apart this printer. All right, everybody. It's the middle of August, and I've decided it's finally time to answer a question that I've been really eager to answer. So I've got all these connectors to different cables. The other question that I want to answer today is, do we need to free the pins? You can see I've got quite a few pins freed. A lot of those are USB. There are a few IDE. And take this opportunity now to say, you know, you got to protect yourself. Please wear your protective equipment when you do things. The acids here are no joke, so don't do this if you are not comfortable. with the risks. But we're gonna use some hydrochloric. And that's it. That's all that I have in this container. So I will go and grab some more. But before I do that, just explain what I'm doing here. You can already see that it's reacting with some things in here. I'm hoping to get the tin and anything else that this hydrochloric will eat before we move on to the more expensive acids. Nitric acid for me costs a lot, and I imagine it costs a lot for everybody else. But if I can get rid of any of these base metals that the hydrochloric will eat, now's the time to do it. If somebody can explain to me, I have never heard the reason why tin is an issue. And every time I try to look it up, I get the same answers from other people, which is, you just don't want it in there. However, nobody's ever explained to me why. So that'd be great to know. If you guys know, please leave a comment. Okay, so it's been about a week, and I found some pretty interesting things. I think the most interesting thing that I've discovered is that there's copper in more things than I realized. So let's look inside some of these connectors first before we move on to the copper. You can see inside this connector here, it has no pins anymore. They were completely eaten away. If there was gold plating on it, it's in the solution somewhere. These power for hard drive and CD-ROMs, these pins are also completely eaten away. So whatever the pins were made out of, just straight hydrochloric acid ate them away. And again, these are SATA connectors, and there's no pins in there at all. So these pins were completely eaten away. But then you can get to these pins in these DisplayPort and USB, and the pins are all still here. Let me see if I can flip one of these around. It's kind of hard to see in there, but you can see that there's pins still down in there. The thing that's the most interesting to me is that whatever was on the outside of this connector has been eaten away and has been completely removed to the point that you can see the copper. And you can see that this USB, it also has copper under there. But then you can see that there's an HDMI cable down in there. That's got some copper as well. And I believe so did this one. Yeah, you can kind of see that copper in there under all that stuff I didn't clean off. However, this DisplayPort connector does not have copper. So it's not a guarantee that all of them will, but I just thought that was really fascinating that that some of them are actually copper. Oh, hey, look at that. There you go, some gold. Some gold pins right there. You can kind of see that tint of gold. So the hydrochloric did not destroy these pins. They did not get eaten away. And you can see that the gold is actually still present. All right, so this is what I ended up with. This is a really nasty mess of just, well, everything. This dark, nasty stuff. But it bubbled over, and I think it'll still work, but I'm not too sure I want to keep using it once it's damaged these heating coils. But for the most part, it's still technically functioning. But yeah, my mistake is going to be very costly. It's probably about, I don't know, $15 worth of acids and a pain in the neck to clean. So, not to mention all the loss in potential recovery. I was optimistic I would get more than a gram. In fact, thinking about it now, I probably only would have gotten a quarter to a half of a gram from these. I've got a lot more pins. I will do this again and keep a better eye on stuff.